Well, welcome everybody, and it's great to see you as always. This is a super special event, I think, for us to have Craig Hartman here and his sidekick Patrick Ward, who's a former student. Craig is an alum of this college, maybe 73, something like that. Has worked for SOM, Skidmore, Owens and Merrill, I believe his entire career, is that correct? And I just have a few things to read from his bio, which is online. He's from San Francisco. But we had this conversation the other day about setting and context. And Craig's first paragraph describing his achievements reads, he's a senior consulting design partner based in the San Francisco office, having done work in the US, Europe, and Asia, with very diverse types of buildings, projects that he's worked on. Big range from civic to commercial to cultural. And he consistently adheres to a rigorous modern vocabulary that acknowledges issues of place involving climate, physical and cultural landscape, and historic precedent. And that's some of the things that we talked about the other day. So I really like that intro. Again, I don't want to, he's been recognized with more than 220 awards for design. He's an amazing architectural designer. And I'm just very grateful that he's here to share his work. So if you can join me in welcoming Craig Hartman.
Thank you, Andrea, and welcome to all you bright young, soon-to-be architects, designers, construction managers, landscape architects. Anyway, congratulations to you, because I have to say that you have been selected, first of all, in a rigorous program. Secondly, I know all of you have unique conditions and aspirations and passions, and so with this education you can go in many different ways. But probably most of you will be involved one way or another in physically creating places, things, objects that are critical for the environment and for human use and human shelter. And this is what differentiates our art form from art as fine art. You're creating shelter, you're creating places for people to inhabit. And today, it is extraordinarily important that those places that you create acknowledge and incorporate and work with nature and the natural environment. So, I was in your place, oh my gosh, a long time ago, although in this room, but when I was almost your age. And I found that the education that you receive here is of enormous value in inculcating the fundamentals of what it means to be a creator of these places, spaces, and things. And I'll just reference my favorite ancient philosopher, Vitruvius, who all architects, eventually you'll hear this name many times, first century master builder. And he talked about trying to boil down what architecture really meant. And he said that architecture has meaning, has three pieces, three components, three values in equal balance. And they are firmness, that is to say, buildings are well made. They are constructed with the kind of, today we call it engineering science, that can persevere, last for the ages. That they possess commodity, that being functional aspects, that they function well for intended use. And finally, in my opinion, almost most importantly, and most difficult to achieve, is delight or beauty. And without delight and beauty, delight to experience, delight to use, delight to behold, architecture won't last very long. There's some very high-performing buildings. If you've probably heard of LEED, LEED is an environmental system that evaluates the quality of performance of buildings environmentally. And the first LEED Platinum, that's the highest level we can achieve. That was achieved in the state of California about maybe 18, 20 years ago, is about to be torn down because it is just plain, flat out ugly. So the desire to create things of beauty is really, really important and something that you have to hang on to great value. So I could go on a long time about what it means to be an architect and my own experience, but Andrea asked me to specifically talk about a building I designed about, was completed now almost, 10 years ago, I guess, a cathedral in Oakland. And this is quite unusual. Obviously, not many architects have a chance to design a cathedral, but I think that there are some interesting lessons that can be taken from this, even though it is quite a unique kind of project. So I don't know if it's legal to take this mask off at all. Okay? Otherwise, I'm going to hyperventilate. Oh yeah, we had good, we got a good distance. Terrific. Wonderful. That's perfect. Okay, so this is a cathedral designed, as I said, it was designed, built actually almost 10 years ago, designed even farther back. And this was the result of a design competition, a long selection process. And in architecture, you'll find yourself confronting this as a competitive, and I use architecture metaphorically for all the disciplines that are incorporated in this school. Interior design, construction management, architecture, planning, landscape architecture, they all involve similar kinds of issues that are related, different kinds of emphasis within the different disciplines. But so in architecture, it's a competitive profession, which is great, it keeps you on your toes. And this particular project, because of its importance, was subject to a long process of selection. So very quickly, I'll just tell you about that so you get a sense for what you do, even after you've been around a long time and have a reputation, so forth and so on. Everyone still goes through processes like these, typically. So this involved first submitting your portfolio of work. And by the way, one thing to think about in your time here at the university is to work on your portfolio. And when you get out, when you're graduating, you're trying to get your first job. First job is super important because it will set the stage for what you can do going on forward. So your portfolio, in architecture at least, is really important. So focus on keeping your work together, on doing some projects that really are meaningful and work well, and that you present them well, and do your portfolio. So we had to present first of our portfolio of professional work, then and resume and so forth, and then a process of visiting work that we had done with various architects, and these were architects from Europe and the East Coast, West Coast, U.S., Mexico, and then that was followed by winnowing down to a written essay that we all had to do about various kind of really profound questions, followed by an interview, and finally the group of 16 or 17 architects we winnowed down to 3, and that was myself, an architect from Mexico City, and an architect from Switzerland. So we then did a competition, design competition, and eventually my work was chosen, I was chosen as the architect. So there's more nuances to that I can tell you if you're interested, but I'd like to go ahead with showing you the work. So when you think about any building, as Andrea said in the beginning, or any potential opportunity to work in a place, you have to think first about what is the nature of the place. What's its culture, what's its landscape, what's its climate, what makes up the physical essence of the place. And with that, you need to take certain values about the kind of projects that is intended to be built. So in the case of a cathedral, I felt that one of the most important aspects of a cathedral is light, natural light, the poetics of light. And you'll find that this is true whether you're designing a cathedral or you're designing a classroom or a courthouse, that natural light is fundamental to making places of delight, I think I mentioned earlier. So that was a beginning. And in the case of this building, also issues of inclusion, issues especially of environmental sustainability, because if you're making a cathedral, after all, you're honoring creation, you're honoring the essence of Earth, and so you want to make a place that's going to be a good steward of our environment. So these were some critical points. So I began with this, and I'm personally very influenced by, I've been very influenced by art and by these issues of materiality, structure, and form, and how material and space really needs to be informed by bringing material together to create space, the essence of structure. And this was the kind of qualities or issues or kind of ethos, I guess you might say, that was inculcated in me at this university, at this school of CAP. So the issues of light, in this case of a cathedral, was almost as important as thinking about the columns, the beams, the materials that hold it up. It actually was, in my opinion, almost like a material they used to build. We think about these images you saw were images made by an artist who made lengthy sojourns into the outback of Australia and made these photographs that were pretty extraordinary. And in the Bay Area, where I'm from and where I'm now living, originally from Indiana. And by the way, there's another thing we talk about later on about the influence of this place of Indiana on kind of things at least I and probably you, if you live here, wherever you come from, carry with you and how that can inform your thinking. So in the Bay Area, the qualities of light, natural light, are really interesting. They change from what we see here to being very crystalline daylight to very flat light in the fog. And these qualities are really make up the way you think about the world, about the place, these qualities of daylight, and certainly about the way you might think about making architecture. And with light, the contrast of darkness, of shade and shadow. Without shade and shadow, you can't really understand or perceive form or the essence of light. And Tanizaki, the great Japanese poet, talked a lot about the essence of shadow and light. And his simple book that you can read is really, I think, for me at least, was very inspirational. And so these places that you can see in the natural realm, these are slot canyons in Utah, and you can see the importance and the power of light in the natural world. And of course, artists, forever almost, certainly Caravaggio and forward, have been really focused on the essence of light in their work. And of course, as an artist, one of the reasons I like art is that you can see the almost, nothing's perfect, almost perfect manifestation of intention. And that's very difficult to achieve as an architect. I've never been 100% satisfied and think that the work is great of anything I've done because it involves, but because it involves many hands and sometimes compromise. But the work of artists, to me, I find to be extremely influential. So Caravaggio's light, you can see light and shadow, was just extraordinary. And when I was a few years before starting the competition for the cathedral, I happened to have the opportunity to be in New York at Wendia Foundation on 22nd Street and saw the first installation of Richard Serra's torqued ellipse. And if you've seen these or experienced them, these are these massive pieces of Corten steel. They're shaped to form spatial conditions. And to see these together and to experience one is just really, to me at least, a profound experience. And at the same time, across the street at also the Dia Foundation was an exhibition of Fred Sandback, who makes also space, but with the most minimal ephemeral means. These are small cords you can see. There's actually a piece of wire, but he stretches cord often between rooms to transform space. So that contrast of weight, lightness, and space to me was really, really interesting and profound, and thought also something when we think about in considering a cathedral. As an architect, as a young architect, travel is extremely important. So take every advantage you can of the opportunity to travel. This is Rome, of course, and it's Borromini's small chapel at Quattro Fontane, which is an intersection in Rome. But this was designed in, the 15th, 16th century. And you can see the fluidity of the space, the way the light works with that space is just incredibly powerful. Of course, this is done with no computers, all by hand, working with craftsmen to achieve, but the geometry is almost perfectly achieved. And you'll know, if you don't know now, you will learn about the other great masters of the 20th century, the great masters of modern architecture. Corbusier, of course, of this building. This is Ronchamp in France, the chapel, the Ronchamp. And it's much smaller, by the way, than it appears. When I was maybe in my 4th year, I had the opportunity to travel and went here, and I was stunned at how tiny this building is. But the way that these modest materials are brought together as space is shaped to be ennobled by light. The depth of this wall, the raking light across modest materials of plaster and stucco is just extraordinary. And a few years ago, with Anna DeBrea, who was a professor here at school, asked me to go to Buenos Aires to do a bit of teaching, and we took the opportunity to go to Uruguay to see the work of Eladio Deste, who worked with farmers and construction workers to make these incredible spaces. This is a church that is made of all brick, in which the form, the essence of the shape, you can see the curved forms here, are actually to create structural strength and lateral forces, to resist lateral forces, and the way, again, light really ennobles this most modest of materials of brick to make this beautiful, beautiful space. So light is really transformative material to work with. This is the Air Force Academy chapel in Colorado Springs. Happens to be the architect whom I first went to work for at SOM, who was a partner in their Chicago office. He taught here for a couple of seminars over time, and actually through that I was invited to go join them, and which I found to be an extraordinary experience. Obviously, in my entire career now, plan to be there for 2 years. But this is the interior of it. You can again see how light and the use of small amounts of stained glass to transform aluminum. So you are in a moment in history, planetary history, in which we as human beings are shaping what the planet is and its very viabilities for human life. So as architects, planners, city planners, you have enormous power to affect the natural environment. Almost 2/3 of the carbon dioxide that's emitted comes from our buildings that we produce, how we move between them, and how we operate them. So as architects, designers, and planners, you have enormous opportunity and really responsibility to think about how we can deal with the fact that we have less resources on Earth, natural resources, less biomass support than we have, and more people than we have to be supported by that. So for sure, we've seen even in the last decade that there are ideas in city planning, in architectural design, in transportation, in technology to radically reduce our consumption. And reduction of consumption at all levels is important. And that even means being careful about what you build. Always try to be efficient in the way you use material, the way you run your life, in conserving water, energy, and consumption in general. So this is the setting for the cathedral in Oakland. It's on a lake, you see there in the foreground, which is connected by an estuary to the Pacific Ocean. It is, the site you see there circled is at the very end of this lake, and it has a long axis, I term the axis of nature, which connects that site to the lake itself. And being on or next to or connected to the Pacific Ocean, it seemed that there were some larger metaphorical possibilities in the way we think about architecture, or this work of architecture, and to think about the fluid, the fluid nature of the ocean, of course, and its inhabitants, but also this sort of softness, fluidity, the gentleness of Asian Pacific Rim culture really influenced the way that I thought about how we might begin to think about form, and about form that might be soft in this case, that might be fluid, and especially it would respond to the commodity part of Vitruvius's triad is the function that the Catholic Church. I'm not a Catholic myself, and so I really relied upon sort of research with Catholic scholars to make sure that what I was proposing wasn't crazy, and found that there was in 1962 a reformation of the overall orthodoxy of the Church, including the way that the churches and cathedrals should be organized, so that as opposed to a linear basilica form cathedral, the great cathedrals of Europe, if you've seen them, the Roman cathedrals are all long and thin. That's based on an early Roman basilica form that was a kind of a marketplace. And the idea about that linearity was it meant the priest was at the front, or the bishop, and so your sort of relationship was you, the bishop, and the bishop to God. That was kind of sort of the hierarchy. So the Reformation idea was to create a community of people about the altar. So you were as one, as a community. So this presented some interesting possibilities and also some real challenges, because the great basilica form cathedrals, the ones we really know and admire, their iconic shapes. This sort of fluid bulbous form, to me, instantly was a question about how do we resolve this to achieve the third point, which is of beauty and delight. So that was a study, and knowing that all of our work should be informed by geometry. And the early cathedrals, are, of course, the geometry. If you look at the plans, they are really rigorous geometries in plan, and even taken to the third level in its in 3 dimensions. So this particular plan, I noticed that if we took two circles and made them intersect, we could create that shape you just saw in sketch form, as you see here, with the 2 intersecting pieces of that circle to begin to form that shape. And so, and it didn't take long to go beyond that to see the shape that you see, that the sort of reference to the fish, which is from the early Christian symbol of a stick in the sand, with one believer would make a circle this way, and the person who met on the beach, because this was a time quite dangerous to be a Christian, would make a circle the other way to form the Pisces symbol, which said they were of a common belief. So anyway, it's just sort of coincidental or interesting that this form now has been observed by the Hubble telescope and other distant galaxy observation techniques to see nebula, star nebula that form the same kind of shape of the universe. That's maybe coincidental, but interesting. So then to take in architecture, the way we start is always with beginning with pencil sketches, or with now with the digital sketches, and with 3-dimensional models, begin a rough study of how we get to form. In this case, once you've done that, then you want to begin to find ways to create rigor and clarity around that form. So after developing the intersecting circle idea, we took the next step to begin to form really what the plan might look like. So you see these deeper walls, and the idea that the circle could begin to form a field of repetitive geometry that formed the overall space itself. And then to take this into the third dimension, again, like the great Gothic cathedrals, we took the next step of taking that plan geometry, the circle, and making it into a sphere, and taking those same spheres and engaging them, just like we did the circle, to create a form that, when we cut it, can then begin to reveal a spatial idea. So this is the, and this wasn't kind of a automatic kind of thing. We began with sketches and model making to see what kind of form we were to get to, and then applied this geometry to clarify it. So this became the shape of the building itself on the inside, and I wasn't pleased with that shape as an exterior expression, nor was it easily constructible, because as a compound surface, it bends in two directions in a plan and elevation, so that's very expensive to build. But we knew we could make that out of wood, and so we'll talk about that in a moment. But then to enclose that, if that were wood, a simple way to enclose it would be to make 2 conical segments that can be made of flat plates and stacked up in a way that's really pretty economical to build. So that was the essence of the beginnings of the formal thinking. And then the site itself, always the kind of the piece that was generating the thinking about this, was what you see here. It was originally a parking lot next to Lake Merritt, and you can see there was a 16-foot separation between the parking lot and the lower level that was the lake, and the upper level, which was the level of the city. So we had that 16-foot strata. We had a very long site, but we had this other strata to think about, and how we bring the city together with this site. Well, that presented some really interesting and really great opportunities for us, because basically, in addition to the cathedral, there were a lot of support things that go with it. The dependencies included conference rooms, bishops' offices, and offices for the diocese, a mausoleum, a parish hall, a conference center, parking, all this stuff, cafe, bookstore, a rectory for living, and the cathedral. So in order to not have the cathedral totally subsumed by all these uses, we're able to take that 16-foot datum and use that as a strata in which to place all the things you see below here, below the lake level, or at the lake level, not below, but at the lake level and up to the top. So this created an opportunity then to create an artificial ground plane at the level of the cathedral and let the cathedral be really dominant in the landscape. And to form this series of spaces that you see here, a park, basically, an Olive Garden park that's open to the public, a plaza, entry plaza, and make it really open and dynamic place for the city where people could move through it, and around it, and come and stay, and not even necessarily go into the building itself. So with this, there were some really critical issues then around how the cathedral was placed on this site. And so you see, we've turned it, and that's turned very specifically to take it away from the axis of the city and bring it to the axis of nature. There's a pilgrim's pathway, we call it here, which is a yellow line that brings you up from the street by a ramp for wheelchairs to get up to this. And then, of course, you can come directly through from the city to this edge, or by civic stair steps here to the lake level. And then the axis of nature is at roughly 22 degrees. That, I think we'll show up here, there it goes. That then became the axis in which we turned the cathedral to honor that axis and connect directly with the lake. So the cathedral was literally turned away from and skewed away from being actually the city's geometry and make it the geometry of the lake. Early study models you see here, one is this, you see this bell tower of glass, and the Fibonacci sequence defines it. Didn't have the budget to build it, that's a future fundraising opportunity for someone. But you see the cathedral in shape beyond. So the cathedral is made of two layers. The one I first described as these spherical segments made of wood, and then the outer layer, which is made of glass and steel, which is the protective membrane that keeps the water and wind out. So here's a view of this, and we're thinking about the glass in ways that we could use current technologies around the ceramic fritting. It can be embedded into the glass. This is, you can see, 5 foot by 10 foot, that's a one piece of glass. And it's organized with this fritting so that we have a translucent, transparent, and opaque glass that is organized in a very organic and yet abstracted form. And it takes its inspiration from the forest. You see it here closer up, and so it helps to emit really dappled light to the interior. So here are these layers sort of stacked up. You'll do drawings like this at some point in school. It's called an exploded axisymmetric. It's a way of looking at the way that materials and spaces come together. You can see the reliquary wall at the base and the seating bowl, the conical segments that surround the center sphere, and then the glass that surrounds that, and the rooftop, which has glass as well. So this very powerful wall at the base, we've dubbed it the reliquary wall. Relics were kept in cathedrals in the past. In this case, we've called it a reliquary wall because we've used it to carve out space within that thickened wall. It's 15 feet deep at the base. It steps up. And within it, we have chapels, we have shrines, and we have also openings that connect through to the city. So here's a view of that plan in detail. You can see the altar in the middle. You can see the gold lines that go out from it, or that slice through that reliquary wall to open up and make connections to the city and to the lake. And then the blue line that connects through from the baptismal font, and then coming through the main altar and the sacristy at the end. And then here is an ancient olive tree that we brought from Jerusalem that makes that connection complete. So we always study these elements in three-dimensional model form. And of everything we can get, cardboard, wood, these are some wood models we use to study this. Again, looking at, in this case, the altar, a cubic piece of stone, and a circle. So a square and a circle in Asian culture means heaven and earth brought together. So very powerful metaphor. And you can see both the main axis here and the ones that cut through the reliquary wall to open it up. Another study for the reredos wall that forms the backside of the altar, again made of an individual piece of wood. You'll see that later. And here's a cross section cut through laterally through the building. And you can see with these circles how the two circles, these are exact same circles in plan, are used then to define the interior of the sanctuary. And you can see, but more importantly, is the organization of the mausoleum below the sanctuary, and then these great spherical walls, which are actually made of timber, of heavy timber, and we can talk later about the reasons for that, designed to reflect light indirectly into the space. And it's topped by an oculus ceiling, this actually skylight that forms the top of this piece. And here's a section cut in the other direction. Again, you see the mausoleum at the base, and you can see that in yellow there, the connection between the altar in the sanctuary and the altar is called the catafalque in the mausoleum. And you can see at the other end, the baptismal font at the top, and that also connects to the entry into the mausoleum. So there's an idea here about, again, the circle, about in this direction, the circle of birth, life, death, all brought together in this piece. So the circle is a very, very powerful metaphorical symbol in many religions because it has theoretically no beginning, no end. It suggests infinity. Here, though, also is a really interesting opportunity. Well, in California, we have earthquakes, and so the earth moves. That's a big problem for architects and structural engineers. So what we've done here is to actually separate the building from the earth. We've done that by this yellow line here is actually a zone in which there are almost like roller skates. There are bowls that have a round bowl, that has within it a flattened ball bearing. These are big, 5 feet in diameter. And so in an earthquake, the earth can move, but the building will very slowly begin to move on those bowls, on those little feet. And then, because acceleration is in velocity, is what causes the damage in earthquakes. So this allows the building to be very gently brought back to its original resting place when the earthquake is over. So that zone then also allowed us to think about a way of heating and cooling this building. A building of this height is 100 feet tall on the inside. If you imagine, trying to air condition that whole space, it would take the budget of all of Oakland, I guess, just to supply the energy. So instead, we're only cooling the lower 15 feet or 12 feet that we occupy. You see in blue here. This is called displacement cooling. So in big spaces, you could do it in this space if you wanted to. You introduce air low in the floor, and it comes up through openings. And because cool air is heavier than hot air, it just rests in the area that is like pools of cool water where you're occupying the space. So this allows us to be very, very economical with the way that we condition the space. And then at the top of the building, we introduced vents that open when it gets to be like over 100 degrees at the very top, where there are no people, of course. And this causes natural convection. So with the heavy concrete, that's called thermal inertia, in the evening it's very cool in Oakland, in the day it gets very hot. The cool air simply comes up, is pulled up by its convection into space. Now we also have air conditioning that's available. We don't have to use it very much, but that's the system. So again, it's an idea about working with nature, about working with the inherent qualities of natural places, climate. Light is so critical. I mentioned it. Also, not only daylight, but also the way you light the building in the evening. So we've lit the building in a way that lights on one side. Over here, illuminate this space, and then likewise the other side like this. And the effect is when you're in the building, it's like light is coming from the altar. We do all kinds of studies, and study models are the most effective way to do this. This is a cardboard model that we made, and we use a laser cutter to cut these little holes in it to emulate perforated metal, and study this in a conference room to look at the nature of light coming through the oculus I mentioned at the top of the building with the skylight over it. This was rather expensive. The construction manager who was controlling costs said, Hartman, why would you make a big skylight and cover it up with something like this? And I tried to explain, and it was difficult to explain because it was expensive, and it was indeed a skylight being covered up by this piece, by this veil. But that veil is what really created the poetry of that space, because the way light would strike it, bouncing on its neighbors, it made you aware of the presence of light. The bishop happily sided with me and rebuilt it happily because it was really a critical piece of this. The organ in the space we used wooden pipes as opposed to metal pipes, organized them in kind of a natural way, organic way, as opposed to the symmetrical way you normally see them. So it's like a grove of saplings within this wooden building. Art is a long story about this. I'll try to simplify it. The bishop again, wanted in this very abstract space in which this is all about natural light, about material and space and form and people, not about stained glass windows, which were a way in medieval pre-literate days of telling the biblical story. It was a way of making people understand the gospel. In this case, we're in a literate society. So I didn't want to do stained glass windows, and he said, you understand that, but he said we need to have a traditional form, a representational figure, as he called it. So that's what we see here, a figure of Christ. And to get there, I asked him, so what does Christ look like? And he said, well, go to the west portal of Chartres Cathedral in France, and you'll see this figure, which you see here. And so we use that as the basis of what Christ would look like. As you know, there are many variations of this idea, this theme, what does Christ look like? Which is one of the reasons that we wanted to actually kind of avoid using an artist, because an artist, of course, is going to always interpret images through his or her own cultural lens. We wanted this to be something that you bring your own values to. So here's the image. In order to do this, we translated the shade and shadow, we mapped it, and then made that into bits and bytes, and created a sequence of about 96 different openings from 1/4 of an inch to 1 inch and 1/4. And if you know the work of Chuck Close, the great portrait artist who passed away recently, he made these incredible portraits out of pixels. And when you're up close, you see only abstract openings. When you're back in the distance, you can really understand the object. And so that was the point here. We're in a big space, and we needed something that would really convey the image in this large space. And so if you were standing up, maybe you're in the front row, or where I am, this looks like a bunch of holes or a bunch of white dots in gray. If you're in the back, you probably can begin to see a figure, a face emerging from that. And so that perspective and that use of shade and shadow again was what we used. And so again, mock-ups, we did computational versions. We actually then took a big piece of plastic, used our laser cutter to cut it, as you see here. Put this up, put some tracing paper for our composition glass, lean up against that, so say, yes, it does work. So we brought the bishop over, he says, congratulations, you guys figured it out, because the alternatives to this, I gotta tell you, were not good. So this was a critical thing to make this work. There were versions that someone had come up with a big medallion hanging over the altar and with sun rays going off of it. So it seemed like a good outcome overall. It seemed like it still was an experiment. We knew we were highly confident it was going to work, but it was an experiment. So going from there, other elements of the building that take this theme further, the Fibonacci sequence is an organic mathematical sequence you may know about. We use that throughout the building in many ways, one of which is on the door handles. The Fibonacci sequence you can see in many forms in nature. It can be typhoon, swirling typhoons. You can see it in a sunflower seed pod in the contraposing spirals. That's what you see up here on the left. And so we actually used that model, the sunflower seed pod, and we extruded that out using our computers to extrude that out. So the spirals became longer as the door pole got longer. And so we did many tests. I started off with some sketches I was doing, and then we did these translations. We did a three-dimensional, we printed out a three-dimensional physical mock-up of this in plastic, put it on the wall to see what it felt like, and you can see it there. And then we sent it to the fabricator, who I thought would simply take a 3D milling device and cut this out of steel. Instead, they did what we did. They made their own. They took our files, created a three-dimensional print out of styrene, put that three-dimensional print and wrap that in a ceramic mold around it, cast around that, and then like an ancient lost wax technique where you melt the wax out of the mold, they melt the styrene, and out of that came this piece of very heavy cast stainless steel. So that was the piece. It showed up one day before the dedication mass. It was a great thing to have done. So I'll try to wrap this part of this up quickly here, but you can see that this mock-up, we thought we had to mock it up on the site. This, by the way, was the way the building was built, with this scaffold tower with the ocular ceiling built up there, and the entire building was built up to that. We'll show that in a minute. The day we went out, this is all about light. You can see here on the upper right-hand side, You can see the mock-up was placed on a column, and as we walked in, we had the bishop and several other people, 18 or so people, and it dawned on me this could be a real problem because there was strong daylight on the face, and this depended on seeing light coming through those pixels, those openings cut through the metal. Without that, it was going to be washed out, which is what you see there. It basically looked like a blob of metal with nothing on it. My career seemed to be quickly going down the drain, and everyone was sort of scuffing their feet around it. And then the contractor said, that morning looked pretty good. So he said it looked really good, and he said we talked about the light. So they looked around and said they found this dumpster that was laying on the construction site. Took the tower crane, attached it to the dumpster, lifted it up, and created a temporary eclipse of the sun on that piece. And so Christ kind of leapt out of this piece of metal. Now, you probably can't see it so well here, but maybe in the bathroom you can see it better. But you can see that the face just literally just came out of this metal. So it was a miracle, shall I say. So I'm not sure how many miracles you have to become a saint, but we have one there I think was a miracle. So anyway, this was the construction. You can see it being placed up in place. This was very happy. We saw this finally come to fruition. One of the things I think is so beautiful about it is, metaphorically, it really is taking a 6th century work of art, of sculpture, shade and shadow, and brought into the 21st century through light as a veil. So from being this massive piece of stone, it becomes this very ephemeral work of light. Your work, you'll find you have to sometimes, we say, trust the process, conceptualize the way simple work, and then work it through, even if it hasn't been done before. Brunelleschi, his famous dome in Florence, he had to invent the construction technique, and there's a book about it you can read that talks about how he invented the process to make this dome even possible. Here, it wasn't quite that much invention, but nevertheless, it did involve thinking about the construction process as well, erecting these ribs, which were made of wood in Oregon, and brought to site by a truck and then erected in place. And then you can see as the structure starts to go up, again, the spherical forms and the conical forms around it. I was very happy when I saw this. This was in construction. You can see the effect of natural light here, the way it was really kind of beautifully reflected into space. This isn't about direct daylight, it's about poetically introducing light into space, and about the way the light penetrated the reliquary wall I mentioned. So here it was, after a couple of years of concrete and so forth, all of a sudden this wood came up very, very quickly. People were just astounded to see this, and people were very sad to see the glass go up around it, but for me that was really, the glass is really important. Practically, it has to be there, of course, but also it's very important in having this duality of the outside and the inside. And on the exterior, we have a building of great luminosity in which light can strike from the roof, which we have a glass ring around it, the backside of the glass, which makes it very, very luminous, very light. You're seeing a building actually in light, not light on the building. So it's a sort of different way of seeing architecture. And as light moves around the building, it transforms this very luminous structure to be one of, when direct light on it, becomes one of very much solidity. This is the inside, so then one of the things that's really, I think, really interesting about the building is that change from that very ephemeral quality of the exterior to this very visceral, of the earth interior, made of wood and concrete. Very simple, the most simple and most modest materials. And wood, of course, as a renewable resource, was really an important part of thinking about this in terms of this environmental stewardship. Here's the view from the altar back to what we call the Omega wall facing south. Again, the geometry brought together here with a diagrid to resolve the two geometries coming together of these metal pieces that reflect the light in ways that are very interesting as the sun moves across it and brings light into the interior. Here is the oculus ceiling that, again, if it was just a skylight, you've seen these skylights in airports, but when you introduce another device that mediates the sky, the light, and begins to create more poetic ways of introducing light, it becomes much more meaningful, and I think has a much stronger spiritual connotation. Cut through the piece. Of course, one of the wonderful things about a building like this is its its connection with humanity. So when the building was dedicated by Bishop Cummins with sacred oils from the sacristy, he first put this on the altar and then went around during the Mass around the cathedral with making the sign of the cross at the stations with oil from the sacristy on the wall. And the beautiful thing is, even 10 years later, you can still barely see those marks, and they slowly become, that touch of that time becomes very slowly becomes embedded and evolves into the architecture. The Royal Quarter wall I mentioned, again, it's all cut through to connect to the city. It also provides opportunities for very, very intimate, small side chapels next to this large sanctuary. So within these, there was an opportunity to introduce color, to think about light again, and very, very trying to conceal the source of light, but try to present the evidence of light as it rakes the walls. The elements here, like the crucifix, was designed specifically to be close, that you can actually touch these relics, these elements, and very much a part of the ethos of this building. The entry, I mentioned the Fibonacci sequence, which was also involved in thinking about the organization of the Royal Quarter wall and its striation. And here you see again the door handles. The circle you see is actually traced from the circle of the baptistry within, and you can see the intersection of these two. So it presents this liminal space. If you don't know what that is, you can look it up, but it's, well, it's a liminal space is a transitional space. And in two intersecting circles, that space is considered liminal space. So this idea of transformation as you walk into the city, then into the sacred space, is a liminal space, and it's conveyed by those geometries. So again, here is on the left is the baptismal font as you approach it from outside. Below the walls that have water coming down them as you enter the mausoleum. It directly takes that geometry of the baptistry straight down. Here's the mausoleum, a view back to the catafalque. The light comes from here. This is that circle of glass around the main altar, bringing light down into the catafalque from above. And then, as I mentioned in the evening, the reciprocal nature of light, day to night, is very, very important in any building, and this one was a really unique opportunity to do this, to think about the building as a lantern to the community in the evening as it's lit from within. We see the light that was on those, bouncing from the daylight in on those wood slats. Now it's reversed and comes back onto the building. So people typically don't have an opportunity to stand inside a lake and watch this all day, so I'll just do this really quickly. That you can see the effect of daylight as it moves across this building, and again, the presentation of architecture in a different way, in a way that is about light and luminosity as much, or even more so, than shade and shadow on texture and heavy materials. So this presents the opportunity for the building to really be seen in different ways throughout the building and throughout the day and throughout the year. And then in the evening, it does become this lantern that I mentioned. So I think best that we leave it at that. There are lots of other things we talked about in that building, but and I know that most of you, well, maybe none of you have the opportunity to design a cathedral, but I think hopefully there are lessons within this that you can take that mind-informed way you think about your work as you move forward. So I'm happy to, I hope there's time to answer any questions that, I'm sure you have some, but about this project or about architecture school, life after architecture school. Happy to try to answer questions you may have. Thanks.
One question, a super good question, no pressure. Anybody? This is an amazing lecture. It doesn't have to be amazing. Some part of it.
Yes, okay.
How do you get started after you're done with school?
Say it again.
How do you get started after you're done with school?
How do I get started?
Yeah.
Okay. So let me tell you that, first of all, I hate to say this because luck is part of your life. I hate to say that because it sounds like, well, just leave it to luck, But you have to kind of prepare yourself and put yourself in sort of the path of luck. You know, you've heard that story. So luck was part of it. I had planned after school to go on to graduate. I got a 5-year bachelor's of architecture degree here at Ball State. My plan was to go on from there to get a master's degree and then be like Andrew Schwartz or be like Tony Costello or Dean Ferguson, all the faculty you have, be a teacher and then also practice architecture. That was my goal. That's what I saw as my ideal thing. Because they're the sort of people I saw and people I admired. But thankfully for all those hundreds of students who might have had me as a teacher, you're lucky that didn't happen. And I was invited, we had a lecturer named Walter Netsch, who was an architect who came down from the Chicago office of Skidmore, Ewing & Merrill, and taught a seminar, and he invited a couple of us to go up and interview or have a job in Chicago at SOM. I thought, well, okay, maybe I didn't want to do it, frankly. I thought it was too corporate and so on. The dean of the school at the time, a man who founded the college, a man named Charles Sappenfield, and he said, young man, you need to do this because this will be even 2 years, then you can do your dream, whatever it is, graduate school, whatever, and you'll be more valuable later on. So that's what I did. And I was going to be there for 2 years, or maybe 3 years at the most. And well, so I've been in my entire career, which is now over 40 years. So that was my quick story about how I got started, but so it was just sheer luck, frankly, in that regard. But as I mentioned at the very beginning, I think I worked for an architectural firm this summer and did other things you had to do as part of your accreditation here, but I think it's really important that you may not know, well, first of all, I know some of you some of you may not go to architecture, some of you go into landscape architecture, some might go into historic preservation or whatever, or construction management, interior design, but take this first year to really kind of observe, really be a keen observer of what goes on in the school, and what really you find interesting and sort of attractive. You'll see, take a look at what the upperclassmen are doing in landscape, the different disciplines, and see the work. Say, is that interesting or not? Or could you catch yourself doing it? and then with that, you begin to develop a kind of affinity and eventually passion for that work. And that is the most important thing, is to have a real passion and real love for what you do. And that's why I'm still practicing architecture after all these years. I could have retired long ago, but I really love this work. And so that's super important. And for me, it was all about, I really wanted to be a designer. And so that was my passion, that was my focus, and I always focused on that, being a design architect. But maybe management, it may be technical work, technical design or technical execution, it may be construction management. But as long as you really have a passion for it, if you really love the work, there is nothing, so I felt so fortunate to actually be paid for what I was doing in the beginning. Even though I'll tell you I wasn't paid very much. So yeah, that was my brief story.